Welcome back to my channel. So today we are going to see merge sort with the algorithm divide and conquer. So far we have seen bubble sort and selection sort. So what's the difference between those sort and this merge sort? The major crucial difference between these two sort is the complexity, runtime complexity. Whatever sorting algorithms we have seen, which is bubble sort and selection sort, they are having O of n square complexity. Whereas the merge sort, which we are going to see today, it has O of n log n complexity. So you can see it is much more efficient than bubble sort and selection sort. You can see this red area, this is not good complexity. I mean O of n square. Bubble sort and selection sort lies between this, and the merge sort lies between O of n log n. So this is much more efficient. So how it is much more efficient? Let's see. Uh, Whenever we see merge sort, we have to consider two things. We have to know two things, like how do we implement merge sort? The implementation is quite simple. We have to divide this array, I mean find the middle and divide array until array has only one element left and merge those arrays. The way we divide, and that's called is divide and conquer. I mean we divide the array until array has only one element and then we merge all those arrays. So let me take an example and explain you. So we have this array 7, 3, 2, 16, 24, 4, 11 and 9, right? So what's the first step? Find the middle and divide array until array has only one element left. So how to divide array? We got the middle. Let's say we divide this array by 2 and we got the middle of 4. Then we have two arrays, left array and right array. So we have taken two extra arrays. We call it, let's say, left array and right array, and we divide this array. So first four element we put into this left array and remaining four items we put into the right array. But now this array is still divisible because it has a size 4, and what we want to do, we have to divide the array until array has only one element. So let's divide this array, left array, again into the another left and right array, right? So we have divided into the another left and right array. Same again right array, we divide into the left and right array. We do the same process again until array has the only one number, one element. So this array with the two numbers we divided into again left and right, 7 and 3, right? So you can see here same steps are repeated. So in implementation, we can use the recursion because that's what we call it, divide and conquer. We divide into the sub-problem and we find the solution for the sub-problem and we just repeat it. So we have to find a solution for dividing and we have to repeat it until the array has only one number. Okay, this is what the dividing is. Now the merging the array. Once we divide the array, then we have to merge it. And the way we merge it is what matter. I mean, let's say we have to sort this array in ascending order, 0 to 1, 2, 3, 4, whatever it is. So this is what the ascending order. So when we merge the array, we have to compare left array and right array, and whatever is the smallest number, because we are sorting ascendingly, we have to take it first. Let's say this now we are merging. Let's say this is left array, right array, and consider we are have two pointers. Let's say pointer I and pointer j into the left array and into the j into the right array. So we just compare these two first numbers, I mean I and j pointer, and whatever is the smallest number we put here. Let's say 3, 2. What is the smallest? 2. So we put 2 here, right? Then because we put 2 here, we have to increment the j pointer to the 16, but in the left array, I pointer will remain to the first element. Then we compare 3 and 16 and we found like 3 is the smaller. Then we put 3 here. Then we move this pointer to the 7. Then we again compare 7 and 16. Then 7 will goes here and the 16 will goes here. Right? So this is what the merging concept. So both are quite simple. Right? I mean dividation and merging, and both are having the recursion. So if we can see here, like anyway, we are going to see in some time, like while in implementation, like how we are going to use the recursion, right? So what's the time complexity for this? When we see the merge sort, what we have seen with this algorithm, divide and conquer algorithm, we divide the array first and we merge it. So the complexity lies in between, like is includes dividation and merging. So when we divide the array, we're dividing the array in half. Every time we are dividing an array in half, the same way in binary search. So that complexity is O of log n, because every time we are dividing array into the half, half, half. So when the proportion is the half and half, the complexity will be the log n. And merge. So when we merge the array, we are merging entire this array. I mean left array and right array. So the merge complexity is O of n. So the total time complexity for the merge sort is of n log n. But one more catch is here, like for merge sort, space complexity does matter. So why space complexity matters? Because we have seen in bubble sort and selection sort, there is no space complexity. I mean, there is of one space complexity. We are not allocating extra space. But in merge sort, we are allocating this extra arrays, left array and right array. That is what the space complexity. So that is O of n, because we are allocating same size of array, which is the input array. The size is like O of n, I mean entire size of the array. So that's why the space complexity O of n. So let me clear your complexity concept here. Like when we say the time complexity and space complexity, what does it mean exactly? Time complexity is nothing but the time which is taken by the program to execute. So in this merge sort, it's O of n log n, and the space complexity is nothing but the memory which required to execute that program. So sometime we have to trade between the time and the space complexity. Time complexity always related to the performance, how fast your program will execute. So sometimes it's okay to have some extra space complexity because we need some better time complexity. With this array we have only 4 and 4 8, I mean 8 numbers into the array, so that will really not matter. But when we see in a big companies, they have to deal with the billions of data set or millions of data set. In that case, suppose we have to sort the data set which having billions of record, then definitely the complexity will matter. And in that case, if you want better performance, then we can trade with the space. We will have some better hardware, I mean better memory. So we will deal with, I mean put extra amount into the space complexity, but we will use the merge sort, so we will have the better performance. So that's how the complexity works. Yeah, it's okay. Now let's move to the implementation. Although this merge sort bit seems complex, but the implementation is quite easy, because we are going to use the recursion, and we have only two steps, like divide the array and merge the array. So let's move to the implementation. Cool. Mm, okay, we have seen till selection sort. So let's create one method. Merge sort. Okay. What is our parameter? Obviously, it's the integer array. Cool. Okay. Now we'll go step by step. So we have to follow these two steps. Now see carefully. What is our first step? We have to divide the array. And how do we divide the array? We are going to find the middle and divide the array. So let's find the middle. Now we have the array. Now middle. How do we find the middle? Obviously array dot length divided by 2. Then we got the middle. Now we have to divide array into the two array. We call it this left array, we call this right array. So let's define the left array and right array. Let's say integer array left is equal to new integer array. Now what is the size of this array? When we define this array, what should be the size? For the left array size, when we divide into the middle into two part, the size of the first array, left array, definitely it should be the middle. In this case, let's say the total size 8 divided by 2 is equal to the 4. So the 4 is the first left array size, right? Now fill the left array. Now we define the left array. Now we have to put, I mean, input all the left, I mean, input all the numbers from input array to the left array. So let's take a for loop. I is equal to 0, I is less than left dot length. Now this will not be the left of length, but we are going to move this array until middle. I is equal to 0, I is less than middle, I plus plus, right? So I 0 to middle, and we have to put, let's say this is array of I, and this is the left array, left of I. So left of I, that is nothing but left of 0, which is equal to array of I. Sorry, this is not 0, this is I. Left of I is equal to array of I. Then what we did, we just copy the first half of the input array into the left array. Now the second half of this array we have to push into the right array, copy into the right array. Now let's take a right array. Integer array right is equal to new integer array, and now what is the length size of this array? uh, Now it should not be the middle, because in this example, because of array has this 4 and 4 8 numbers, and because of 4 4 should not be the case true every time, and we are going to again subdividing the array into the different array. So the this size is nothing but the entire size of this array dot length minus middle. So whatever the remaining size is the size of right array, right? So let's do array dot length minus middle. So this will be the size of right array. Now fill the data in right array. Let's take another for loop for I is equal to 0. Now this time it won't be the 0, because we have to push the data into the right array from middle. So the I pointer will start from middle. I is equal to middle, and this will be the array dot length, because we are going to the end of this array dot length. Now fill the data. uh, right of now here is the catch. We should not say right of I, because now right array is the new array which we declare, and we need to put the 24 number into the 0th index of the right array. I mean, the input array will start from middle. Let's say this index is 0 1 2 3 4th. So we have to put 4th index of input array, whatever number at 4th index, into the 0th index of right array. So what does it mean? It means we have to put I minus middle is equal to array of I. So let me explain. So what is the I? I is the middle. Middle is, let's say with this example, 4. Uh, 4 minus 4, 0. Then again I will increment 5. 5 minus 4, it will be 1. So array of right of 0, 1, 2, and I will be increment. So we will copy from 24 to 9 numbers here into the right array. So that's quite simple. It's not that difficult. Now we can see we just done with this only first step. Now whatever the second step, third step, or whatever it is, it depends on the actual size of your input array. So we are going to do the same thing, dividing the array into the left and right. So that's why recursion is very useful here. I mean, we have to call the same code again and again. So instead call this method. I mean, this is nothing but method. So we just call it this method recursively, and we will pass this array left and right. Let's say we pass the left array, and we did the same thing again, and again we will pass the right array, and we will do the same thing again. So what we are going to do here, like this code is we are calling again and again with the recursion, but only thing is we are passing left array and right array. You can see here we divide this array into the left and right. Now this array we are passing, and we are doing the same operation until array has only one. So always remember, when we use the recursion, we have to give the base condition somewhere, or else it will go into the loop. Since this function is calling this method again and again, there should be some exit condition, right? So what is our exit condition? Exit condition is we should call this method, or we should divide the array until array has only one number or one element left. So if array dot length is less than 2, then return. That's it. So this is the base condition. Array dot length is less than 2, then return, then come out from this function. Okay. So but yeah, dividing is not the only enough. We need to merge array as well, right? So again, you can see merge also goes recursively. We are merging these two array, left and right. Again, we found this array, then again we are merging this array, and again we are merging until and unless all numbers we are not merged, right? So since we are going to use recursion, let's call one merge method. We will implement it later. And to this merge method, what we are going to pass, let's say we are going to pass left array, we are going to pass right array, and we are going to pass main array. So we need to merge this left array and right array into the some result array, and we have to return that result array. So instead of taking new result array, just take this same array which is input array, and we just use that array. I mean, we will update the same array and we will return as a result, right? So let's call this method. Let's implement this method now outside this method. So yeah, we have this method now. We made it private, merge integer array left, integer array right, and we call it result array. So that result array is going to be a final array. Cool. So now we are going to the merge this array. So how do you merge? So merging is very simple. I mean, we just have to, as I mentioned here, we just took two pointer I and j, and we just compare I and j, and we whatever is the smallest, then ascendingly we merge the array, right? So it's good to use the while loop here, but before to use while loop, let's use some constant or indexes. Let's say I is equal to 0 for left array, then int j is equal to 0 for right array, and int k is equal to 0 for result array. So we will merge into the result array. So that's why k is equal to 0. Let me explain. So while, take a while loop, let's say left array, while uh, I is less than left dot length and j is less than right dot length. While this condition is true, we have to compare if, let's say, not array, left of I, the number into the left of I mean the first number, because I is a 0, first number into the left array is less than right of j. J is point to the right array, right? If this is the condition, then what we have to do, we have to push yeah, result of array, result of k is equal to left of I, because with this condition you can see the number into the left array is the smallest, because if left of I is less than right of j, then result of k is equal to left of I, and just increment k plus plus and I plus plus. Okay, cool. So yeah, we can do one more thing, like instead of writing this k plus plus and I plus plus here, we can just increment into the bracket itself. So that will be the cleaner implementation. Again, we just refactor the code, that's it, nothing else. Okay, if this condition is true, that means the left array has the smallest number. But if this is not true, then we can have the else condition. In the else condition, we can have uh, result of k plus plus is equal to right, because then right number is the small. Okay, right of j plus plus, right, j is pointing to right, got it, yeah. So, and we increment k and we increment j instead of increment ahead. Now, this while loop will work when this condition is true. I is less than left dot length, and I mean left is less than I is less than left dot length, and j is less than right dot length. I mean until left and right array. But this condition will true only in case when right array and left array have the same numbers, like in this case. But sometime right array or left array may have different numbers. I mean, let's say this has now 8 numbers, maybe it has 9 numbers, then left array will have 4 numbers and right array will have 5 numbers. Then the extra numbers which are remaining, we need to copy as it is. So we have to write another while loop for remaining extra numbers. So let's say for while I is less than, I is pointing to the left, right? So I is less than left dot length. What we have to do, we have to just copy this result of k into the left array, right? And we have to write another while loop for mm, j, while j is less than right dot length. What we have to do, result of k plus plus is equal to j. I mean, we are just this is nothing but whatever remaining numbers we are just pushing as it is, because those are already I mean, we already compare I and j, and whatever remaining extra numbers, I would say, which remains, we just push either we either into the left array or right array. We are just pushing into the result array. So result of k plus plus is equal to right of j plus plus. Yeah, that's it. I mean, that's what is the implementation is. So let's test this implementation. Merge sort. Okay, let's go to our main class, and this was selection. Merge sort numbers. Okay, 1 2 0. Let's run with this. 0 1 0. Something went wrong. Let me check. I is equal to 0, k is equal to I less than length, right dot length, left of I, k plus plus, left 0, else result of k plus plus, right j plus plus, and I is less on left dot length, j, oh, here we write greater than, j is less than right dot length, result of k plus plus, then what we write, right, okay, j is less than right dot length and k plus plus, right, okay, cool. Let's go and run it again. 0 1 2, awesome. Let's test with some more data. Let's say 6 1 0 5 10 0 11, some repetition as well. Let's run it. 0 0 1 5 6 10 11. Awesome, implementation working well. Let's test it for one number. Cool. So that's it, guys. We have seen this merge sort implementation now. It is a bit lengthy, but you can see the implementation is quite simple. So if you don't understand, please do let me know via comment. I will help you to understand. And please do subscribe the channel so you will get update of the next video. Probably next I will make a video on quick sort. Thank you. Thank you, guys. Thank you for watching the video. See you.